So today we're going to do our first introductory lab in our new unit. Yes, waves. Actually, it's waves and vibrations. So we'll be looking at waves, sound waves, light waves if we get into it, electromagnetic waves, so all kinds of waves. Let's get started. We have one definition for today, and that's the period. The period is the time required to make one complete cycle. All right, so what do I mean by that? Let's look at a couple of examples. So we got the Earth. So we know that the Earth spins around, and how long does it take the Earth to go around once? Well, its rotation has a period of 24 hours, so it's 24 hours. A couple other things. We have in our solar system. What do we have there? We got this little more complicated thing. We got a sun, we got the Earth, and we got the moon. Okay, all these sizes are very out of scale, right? Because the sun would be way, 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 way long away and a lot bigger than the Earth. Okay, so let's take a look at this. So what do we know about this? The moon has a period of about 28 days. It all depends on how you measure it. It's kind of complicated because it could be like 27 if it's relative to the stars and like 29 if it's relative to the sun. So it's kind of, because everything's moving at different rates. So it's really kind of interesting. All right. But so that's our moon. The Earth around the sun has a period of 365 days. Of course, we all know that that's like 365.25, right? Because a leap year. I think this year was a leap year. And you had an extra day there in February. Clock. Clock give us a great example of period, right? Because what do we get? We get the second hand, this little guy. It takes 60 seconds to go all the way around once, or 1 minute. Minute hand takes 60 minutes to go all the way around once, or 1 hour. And whoop, there we go. And 12 hours is actually half of a day. So that measures half of the period of our Earth's rotation. It's divided into two parts, and the two parts are actually called anti-meridium and post-meridium, AM and PM. So we divide the period of our rotation when we're looking at a clock into two sections. Any of you that use like, we used to always call it military time. I think there's an actual real name for it, but it's a 24-hour clock. All right, so pilots and things like that might use that because that way they don't get confused between AM and PM. So they would say, do this at 2200 hours, which would be our 10 o'clock at night. All right, so what are we going to look at? We are going to investigate what factors affect the period of a pendulum today. So here's a pendulum, which is something that swings back and forth. It has a couple of different parts to it, not very many. It has a string and some mass down here, which is called a bob. This point of suspension we assume is frictionless. We assume there's no air resistance, and we assume the mass of the string compared to the bob is 0 or very negligible. So we're going to look at the period of a pendulum. So what is that? Period is time per cycle, so that's the time to make one complete cycle. All right, in a pendulum, that's one complete swing. So if I start it swinging from here, from there back to there is one complete swing. So that's the period, the time it takes to do that. A couple of other things that could be definitions. Well, obviously the string has a length. The bob has a mass. Those are pretty obvious to us. And then this thing, the amount of swing, has what we call an amplitude. So I guess there is another definition here, amplitude. We'll be working with that a lot. All right, so the amplitude is how far you pull it back from this at rest position, which is called equilibrium. Hey, get back to that word again. We used equilibrium back in first semester when we looked at something that was either at rest or at a constant velocity. We said it was in equilibrium because there were no net forces acting on it. Well, if we look at this pendulum, I lost my mouse, there we go. This pendulum, when it's sitting at rest right there, it's in equilibrium because the force of gravity pulling down on the bob is exactly the same as the force pulling up by the string. Okay, so today what we're going to use is we're going to use a PhET simulation. Hopefully you can run this. This is what I've been doing on the computers last week with the last week's labs. But I think you can run this one on your own computer. If you can't run it on your Chromebook, try it on a PC or something if you have at home, or a tablet would be good. You can do it on a tablet. Or a phone's a little bit small because I tried doing it on my phone and I can't really blow it up bigger. So it's a little hard to do on a phone, but you can do it on a phone, a tablet, another PC, if in fact you cannot do it on the Chromebook. So earlier I said that we can't do these on the Chromebook, but I may have been mistaken. Maybe they've changed it so that you can. I'm not sure, but it was working on a Chromebook for me this morning, so hopefully it'll work for you. Okay, so here's what we're going to do. Okay, so as we discussed, here is our Pendulum Lab, and let's take a look at this. So I'm not sure what comes up when you start the link. So if you get this, just start it. There we go, PhET simulation. Then there's intro, there's stuff about energy. If you remember when we did energy, what happens? It loses potential energy and gains kinetic, so you can look at that relationship. And there's all kinds of advanced relationships in this about velocities and accelerations. Well, we're not going to go through all that. All we're going to do is just look at this part, intro. So that's what you guys want to click, is click intro. And there's our pendulum. So what three factors might affect the period of a pendulum? So let's think about that for a second. Usually we just go through this in class and we brainstorm what we want to test. But I guess I'll just tell you, because let's take a look. We might think that, oh, how far we pull it back. The amplitude might affect the period. So we can do multiple amplitudes, right? And do the period. We can change the length of the pendulum, do the period. And we can change the mass of the pendulum and look at the period. All right, so there's several things we can change here. We can change, we don't want to go to a different planet. All right, so we'll just leave Earth's gravity as is. All right, so you can change all kinds of stuff here. So to get different things. So if you look at the worksheet for the lab, the worksheet for the lab is going to have you do three things. It's going to change the length. It's going to change the amplitude. Whoops, amplitude, bigger amplitude. All right, and a period. Let's see, how do we read the amplitude? It looks like this is, I don't know, 5, 10, 15, 20, 25, 30, 35, 40, 45. Whoops, so this is 10 right there. All right, so if you move it back to there, so I have it out to here. So this is 20 degrees. Oh, I guess it says when you first pull it back. Let me try that. So stop. Let me pull up. Yeah, there we go. So 5. We want to start out with something small like 5. All right, then go 10, 15, 20, 25. All right. So we don't want we're not going to do this. All right, especially if we were in class, because then things fall over, hit people in the head, all kinds of bad stuff. All right. So three things we can vary. We can vary the length, we can vary the amplitude, and we can vary the mass. So go on and do that. And oh, let's show you this. We don't need the ruler here, but let's take a look at the stopwatch. The ruler, well, the ruler is just, we can move it around, right, and measure the length. So if we look at this one, it's to the center of the bob. So that's 40 something. Well, that's what this says right there, 40. So we can use that to measure our length. So we don't need the ruler. All right, but we do need the stopwatch. So the best way to measure the period is to actually just pull this thing back. All right, let it go. And we know that the period is the length of one complete swing. So to reduce error, what I'm going to do is I'm going to do 10 swings and divide my number by 10. So here's the stopwatch. I'm over here by the stopwatch. I'm going to go start, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think I counted that right. I'm not sure. I might have goofed up. I started looking at myself in the little window over here, and I'm like, whoops, lost count maybe. But that's what we want to do. We want to count up to 10 swings. And so then this is 12.77 seconds. So our period would be 1.277. That's why I use 10, right? We could use 5, we could use 9, but it's just easy to divide by 10 in our head. Okay, so that's what you're going to do. You're going to do multiple trials, fill out the data table, answer a couple questions, and send it to me. Or submit it, I guess, on Classroom. All right, let me know if you have any questions.